Hi everyone, my name is Manvith and I'm here to present my final project presentation on the EdnaML fake news project. And I did it on the subtopic of classification and labeling of a Twitter dataset using machine learning. So just a little introduction about the problem. We're trying to tackle misinformation, and misinformation has the potential to basically create social division. And COVID-19 is an infection disease that we all know about. It has caused over 650 million cases and 6.5 million fatalities. And especially during the COVID-19 pandemic, a lot of the world moved online. And during this period, misinformation actually spread a lot, and it caused a lot of uncertainty and panic regarding a lot of topics like vaccines, etc. And it hampered health officials' capacity to respond effectively to the pandemic. It also has the potential to distort reality, meaning that misinformation can cause people to believe in certain things and act based on that, which basically results in social division and conflict. So the motivation for basically finding misinformation is because it's not really an easy task. It's not easy to classify what is misinformation and what is not, because oftentimes news itself is not black and white, it's subjective. And what some people think is the truth is what some people think is false. And one more thing about misinformation is that it often changes topics and context. So it's very topical and very current. So if the current topic is about COVID, it's going to be about COVID, but maybe a year or two down the line, it might not be about that. So one more new thing that I learned through this project was about the new normal. So we were assigned a paper in which we read about that misinformation is now creeping in through the new normal, which is basically a three-step process, which is novelty, where new misinformation basically starts to come into the picture. Prevalence is how some of this misinformation takes the center stage and becomes prevalent and causes a lot of commotion. And then ephemerality is basically after a while it's gone and new misinformation starts coming up, and it's a vicious cycle which continues on and on. So the problem with current classifiers is that they're static, meaning they are tested on less data and on the same data. So they don't really adapt well to changing circumstances, which is what happens in the real world. And our goal is basically to identify false misinformation from large volume, real time Twitter stream uh, with the subtopic around COVID-19, of course. So just a little background about our data set. The data set was acquired from Twitter, and I was assigned the month of February 2021 as my data set. And these are just some of the attributes of the tweet. It's just general stuff. So this was my approach, schedule, and implementation of the project. So in week 0, I conducted data analysis for the toy dataset, which was January 2020, 22nd, if I'm not mistaken. And we obtained various metrics like count, retweeted tweets, average, etc. And we were also instructed to download the base model files for Albert transformer model, which we did. In week 1 and 2, I continued the exploratory data analysis, and yeah, I basically calculated them and also plotted various graphs like time histogram, etc., which we'll see on the next page. So this is it for the toy data set of January 22nd, 2020. Pretty standard stuff, and the time histogram is also pretty self-explanatory. So in the next 2 weeks, I was assigned my data set, which was, like I said, February 1st, 2021. I performed the same analysis using the same scripts. It took a lot longer because the data set was a lot bigger. And I also performed prep work 3, which was essentially we received the EdnaML framework notebook, and we essentially read through it and tried to look at what all it was talking about. So the various tasks which I messed around in it were setup, generating the FNC filtered data set. So I did this for the 2020 data set, and you can see the results here below. So the left side is these results are for the new data set. As you can see, the data set is almost a lot bigger, around Yeah, almost more than 10 times bigger, or almost 20 to 40 times bigger. And yeah, here's the time histogram. As you can see, I think when Abhijit was collecting it, he wasn't done collecting it. So in the later hours, the number of tweets were less. So once we were done with this, now we get on to the crux of our project. So now we basically did all the pre-processing. We got a notebook. So now we have our FNC raw data set from which we create our FNC filtered data set, which is basically just using keywords and trying to find words related to COVID. After that, we basically take this FNC filter data set, we train a clustering model based on it by fine-tuning a BERT model first. And essentially what we're doing through this is once we've segregated for filtered and unfiltered, now in the unfiltered data set, we're going to see which of these unfiltered tweets are actually semantically similar to FNC filtered tweets through our clustering algorithm. And what we're trying to do through this method is essentially trying to pick tweets that don't have a keyword for COVID-19 in the tweet, but are actually semantically related to them. And yeah, once we basically add the thing, we get an FNC similar data set. And when we add FNC similar and filtered, we make the FNC extended data set. And these are all the deliverables which I have submitted. And after that also, you basically train a language model on the FNC extended dataset. This is basically to summarize, translate, predict, and generate text. And my final objective of my final subtask was to sample 500 points from the FNC extended cluster to create a human labeled dataset, which we call FNC Oracle, which we will be used for evaluation and validation. So these are the results. So in the filtered data set, we had 130,000, and the unfiltered data set, we had 61,000. Through our clustering algorithm, we were able to get a 29,483 tweets as neighbors. So those were related to filtered. And yeah, we got a 22.64% extension. And this is the elbow plot for our k-means graph, which gives us the perfect number of clusters. So these are some of the deliverables for what they asked for the project. The FNC filtered dataset, like I described, is just a simple keyword filtered dataset, and you can the link, I mean the path to all of them is in the slide. FNC unfiltered dataset is the unfiltered version. Extended is when we combine FNC filtered with neighbors after running the algorithm. And the main deliverable is FNC Oracle, which is the 500 randomly selected points to perform manual labeling. And yeah, that can also be found in the deliverables. And FNC neighbors is also been submitted. One caveat is that due to Google Colab limitations, we weren't able to run 10 epochs. So the model might not give the best results. But with the current time limit and the Google Colab limitations, I was able to run the model for 3 epochs. And I was able to also like submit all the deliverables. This was the general project flow. You basically get raw data, we clean and process it, we cluster them, we go back if the clusters are not good, train language models, and at any point, obviously, you have to reevaluate and go back. And this is actually a project flow I drew for the proposal, and I feel like it is what exactly happened in the project as well, and it was a lot of iterative going back and forth and trying to figure stuff out. So about the meta skills, I learned a lot, and I think I have to thank the instructor for making this segment to this project. So one of the main things I learned was large scale data handling, which I hadn't done much before. So initially, we started off with a much smaller toy data set, which was a January 2020 data set. But when I moved on to the bigger data set, I ran into all sorts of problems. One of the problems I ran into was memory, which I realized that you could solve using batch processing. One of the problems was that the model took too long to run, so we reduced the epochs, we did more filtering. And yeah, I learned a lot about how large-scale data handling is done. And yeah, that's definitely something I picked up along in this class. Another thing is machine learning and modeling is another big skill I picked up, another meta skill, I feel like, because through this project, I gained a deeper understanding of how to not only like look at the algorithms, but also implement them, which I hadn't really done in a lot of my theoretical courses. And the project also made me do several pre-processing steps, cleaning, filtering, etc., and made me realize how crucial data quality is to the importance of the model, which is something I think I wouldn't have learned in just like any normal ML course. And I also used many advanced techniques like natural language processing, etc., which this course taught me. Communication and presentation was something I definitely sharpened in this course, because presentation wise, we've had to do a lot. I've had to make 2 videos. We've had to submit follow-ups, reports, etc. And I've also like tried to maintain communication with my mentors always. I've emailed them, I've messaged them on Teams, I've been very communicative with my peers, etc. And I think that's the meta skill I definitely picked up in this class, or I definitely sharpened in this class. And finally, not finally, but definitely one of the important ones was testing and evaluation, where I learned how to use a variety of different metrics and strategies, which we can use to basically assess the data and the models. For example, in clustering, we use techniques like elbow method, etc., to find the right number of clusters. Collaboration, initially, there wasn't much scope for collaboration, also because I was doing a solo project. But actually, towards the end, because also one of the TAs left, I think both the TAs and a lot of the students, like we all got into a collaborative mindset. There was a Teams channel, and it was really helpful and definitely a meta skill I thought wouldn't make it on this list, but one that did. And punctuality is definitely one of the meta skills I think I talked about in my proposal, which I really wanted to focus on. And it's one that I try to keep up with, and I try to be as punctual as possible while also providing the highest quality of work. And there were a lot of weekly submissions and project deadlines, etc., but I think I was punctual throughout. Thank you so much for the presentation, for listening to my presentation, and I hope you learned a lot about the EdnaML framework.